Okay, so welcome back. So now we're going to do an example. Notice that we have a repeated linear factor in the bottom. Okay, so now what are we going to do? First, we check the degrees. First we notice the degree of the top is less than the degree of the bottom. So notice the degree of the bottom is 3 because we've got this factor and we've got these. So this is an exponent of 1, this is an exponent of 3. So the maximum exponent on the x variable is going to be 3. So the degree of the bottom is 3, the degree of the top is 1. And so we're fine. So we don't have to do any long division there. So now what we're going to do is since we have a repeated linear factor here, we've got this one, but then we've got a repeated linear factor here that we have to deal with. And so what we're going to rewrite this as, it has to be rewritten, the decomposition has to be written this way. Okay? So we're going, oops, don't want that. Let me do that over. So we've got to have, this has to be repeated as so. So we've got two of these. So we're going to start with the minimum power, which is just 2x minus 1, plus b over the next power, which is 2x minus 1 squared, which is the maximum one, so that's where we stop. Now we got to do this one. So it's going to be plus c over x minus 1 dx. Okay, so there's the setup. Now, this is where we have to set up our equation. Okay, so again, let's set up our equation. And again, I'm going to do some scratch work here. So I do this off to the side. Again, you guys can do it differently. So now I'm going to set up the equation. So this is going to be x minus 2 is equal to, I'm going to get a times 2x minus 1 squared times x minus 1 plus b 2x minus 1 times x minus 1 right? And then finally plus c 2x minus 1 cubed. Oh, hold on. Hold on a second. Let me make sure I'm doing this right. This is going to be right, so remember, you got to multiply through by the least common divisor. So you want to do the least common multiple, which is going to be this. So let me rewrite that. I made a mistake. So this is going to become a times 2x minus 1 times x minus 1. There we go. And then the next one is b, which is just going to be b times x minus 1. And then c is just going to be times, 2x minus 1 squared. Because remember, the least common multiple of these three is just this. 2x minus 1 squared times x minus 1. That's the least common multiple. So this is what we're going to multiply through on the top. And so if we do that, this is going to cancel with one of these, and so we get this times this. And this is going to cancel with this, so we just get this. And then this is going to cancel with this, so we get this. Okay, so this is correct. Okay, now that we got it set up correctly, now I'm just going to use the method of strategic substitution. So let's solve for a. So let's make x equal to 1. Nope, let's make x equal to, what does x need to be here to be 0? Well, that would be x is equal to 1/2. So let's make x equal to 1/2. So if x is equal to 1/2, well, look at this. Here's the thing. And this is kind of a limitation here. Here, it has both factors. We only have 2 factors. So whether I make x equal to 1 or x equal to 1/2, I'm going to end up eliminating a. Okay, so I'm going to be able to solve for b and c. But a keeps getting eliminated, so that's where we're a little stuck, but not stuck, but using the strategic substitution, okay, it can only take us so far. Okay, but let's see what happens anyway. Okay, so if we do this, x equals 1/2, this goes to 0, this goes to 0, and we end up with what? We end up with, well, 1/2 minus 2 is negative 3/2 equals b times what? This is 1/2 minus 1, which is negative 1/2. And so that gives us what? B is then equal to negative 3/2 times what? Negative 2/1, right? Multiplied by the reciprocal. Right? Or divide both sides by negative 1/2, same thing. And so we get b equals 3. All right, so b equals 3. So now, let's do x equals 1. So if x equals 1, we get negative 1 equals, well, here this goes away, so this gives us 0, this gives us 0, we get c times 2 times 1 minus 1 squared. Well, this is usually 2 minus 1, which is 1, and 1 squared is 1, and so we get c equals negative 1. Okay? Okay, now, it seems like we may have run out of options, right? Because we used x equals a half and x equals 1. But now we know b and c now. Okay? So since we know b and c, we can use any value of x and try to solve for a. So let's use something really simple. Let's just choose x equal to 0. So we can plug in b and c here, use a value of x that makes this very easy to work with, and then solve. So now, watch what happens. If I use x equal to 0, and again, this will work for any value of x, but 0 makes things a lot easier to work with. So, if x equals 0, along with the fact that c equals -1 and b equals 3, let's solve this. So, this gives us -2 is equal to a times, well, this is going to give us -1 times -1, which is 1, plus b is 3 times -1, so that's going to be -3, plus c is -1, but this gives us 0 for x gives us a -1 here, which is 1, so that gives us -1. And so now we can solve for a, right? So this equals -4, and so if we add 4 to both sides, we get 2, so a equals 2. And we're done. Well, almost done. Done with the scratch work. So now we solve. Now again, you could use the equation way as well to make equating the numerators. Okay? So again, let's just show you how that works. Okay? So, if we equate the numerators, we know that we get what? We get x minus 2 equals, again, I'm going to write out the equation. So it's a times 2x minus 1 times x minus 1, oops, plus, then we get b times x minus 1 plus c times 2x minus 1 squared. And so now what I'm going to do is I'm going to expand this out, simplify it, and then collect all of the x terms together. So this is going to give me 2, let's do it this way. So this is going to give me a times 2x squared and minus 3x plus 1 plus bx minus b plus c times, and this is going to give me 4x squared minus 4x plus 1. And then this gives me 2ax squared minus 3ax plus a plus bx minus b plus 4cx squared minus 4cx plus c. Okay. So now if I collect like terms, what do I get? Well, I've got a squared here and a squared here, right? So if I put those together, I got 2a plus 4c x squared. And then for the x's, I've got a minus 3ax, bx, and minus 4cx. So if I do this, then that'll give me a, how do I want to write this? This will give me a plus negative 3a plus b minus 4c times x. And then for the last one, the constants, I got an a minus b, and a c. So that's going to give me a plus a minus b, where is it? Oh yeah, plus c. That's my constant. And now I've got my system of equations. So I'm going to set the system of equations, right? So here, I don't have an x term here. So think about this as a 0, right? So 0x squared plus x minus 2. So that means this has to equal 0. This has to equal 1. And the constant term has to equal negative 2. So that's how I'm going to set up my system of equations. So I'm going to set up that 2a plus 0b plus 4c. You don't need the 0b here if you don't want. Okay? Unless you just want to make sure the place values, or the placeholders, right, the columns line up. So we got 2a plus 4c equals 0. Then we've got negative 3a plus b minus 4c equals 1. And then we've got a minus b plus c equals negative 2. And then we do the same thing that we did before. We're going to eliminate, so we've got an a and c. So look at this. So right now we've got opposite signs. So if we add these two, right, just let's add these two right here, the bottom two. The b's are going to cancel out. We get negative 2a minus 3c equals negative 1. And now we've got two unknowns with two equations with two unknowns. So we've got 2a plus 4c equals 0. And now we can add again because these two have opposite values but the same coefficient. So if we add these down, we get what? We get c equals negative 1, which is what we got here. Okay. Then what we can do is we can use the negative c equals negative 1. We can go back and plug into this one and solve for a. So by plugging negative 1 back in here, we get minus 4. So we get 2a equals 4, which means a equals 2, which is what we got here. And then we can use both of those values, right? We got a equals 2. So now we can use these two to plug into this one or this one to solve. So let's do the second one. So this would be 2 minus b minus 1, because this is a negative 1. So it would be what? 2 minus 1, which would give us a 1. And then we add, so we get negative 3. We get a negative b equals negative 3, which means b equals 3. And we got this, the last one. So that works as well. Okay, again, both methods work as long as you set up your equations correctly. Okay, as long as you do the decomposition correctly, you should get the same answer regardless of whether you do strategic substitution or you set up the equality of the two equations, okay? And then you set up your system of equations. Okay, that's it. Talk to you soon.